Okay, you probably got it all written out, even though I don't see a lot of pencils working. So, 4i plus 3j dot 4i plus 3j by the distributive property means you got 4i dotted with 4i. Okay? And I say over addition also, well, we're going to regard it as implicitly. What am I going to write next? All right, plus. Well, actually I'm going to write it like this. 4i times 4i plus 3j dotted with this plus 3j dotted with 4i plus 3j. That's distributing on this plus, right? And that's equal then, well, we distribute over this plus. We get 4i dot 4i plus 4i dot 3j. And then here we distribute, we got 3j dot 4i plus 3j dot 3j, right? And then we're using another property. I'll go ahead and write it out. It's implicit. I didn't write it out, but we can bring out these 4's and say, well, that's 16i dot I. Okay? And actually, I don't want to write the 16. I want to write that as 4 squared. Just so we can keep really explicit track of our Pythagorean theorem. Because that's what this is going to give us. Okay? So it's 4 squared times I cross dot I plus 4 times 3 times I dot j plus 3 times 4 times j dot I plus 3 squared j dot j. Now how does that simplify? In terms of these rules,
60.
what's I dot I?
1.
1. So that's equal to 4 times 1 plus 4 squared times 1. And then 4 times 3, what's I dot j?
0.
Well, okay, that's 0. And j dot I is 0, and j dot j is
1.
1. I mean, the rule is simply, if these are the same, it's 1. If they're different, it's 0,
I
right?
wrote the rule up there wrong. By the way.
I'm sorry?
J dot and J are not well done.
Yeah, and I didn't write, okay, I wrote that down carelessly. I also didn't write the rest of them. You got k, right? And let's write it down correctly this time. K dot k is 1, right? Okay? Big ol' important consequence. The magnitude of a vector is its, what we think of as its length, but that generalizes, as you know, from linear algebra. But in this course, length is okay, right? Magnitude of a vector is the square root of the vector dotted with itself. Okay? Now, we haven't written it out. It can be extended to 3 dimensions and higher. 3 is as far as we go in this course. Okay? So there it is.